In our last video, we saw how to find the length of a hypotenuse for using the Pythagorean theorem for a right triangle. In this video, we're going to see that you can also work that backwards. If they give you the hypotenuse and then provide you with one of the leg lengths, then you can actually just kind of set up the same scenario just with a slight adjustment. We know in general that a squared plus b squared equals c squared for a right triangle whose legs are a and b and hypotenuse is c. So we were given the hypotenuse this time, and it's worth noting, since I haven't mentioned it in the previous two videos, that our hypotenuse is labeled as the side that's across from your right angle. That's always the case for a right triangle, so you should always know that your hypotenuse is across from your right angle. And then in this case, let's just call our leg A. I usually solve for B in this situation, so we're going to call this B. It does not matter which one you pick. If you chose A or B, it will work out in the long run. Now, in the past, we said square root both sides to get c by itself, but we're actually trying to get the b value by itself this time. So in general, anytime I want to find the length of a leg, what I would do is start by subtracting that a squared from the other side. If you chose the other way, if you chose this to be a, then just subtract b squared instead. Then you can do the same thing that we've done before, and we'll get the square root of both sides, and there you go. So just like in the last video, I made a comment that I don't normally work with this form up here ever. I usually go straight to the form I need. I'm really thinking, as kind of a side note here, that if I want to find the hypotenuse, our hypotenuse is going to equal leg squared plus leg squared, basically. We're going to just take the two legs and square them and add them up. So maybe we'll say leg 1 and leg 2. And our sides, or our legs, let's say leg 1 is just going to be the hypotenuse squared minus the other leg squared. And that's just always the case. So this is kind of a little sidebar of mine. That's not really super relevant to this problem, but I thought I'd make a note of that here, because otherwise this is just a matter of plugging in values. We're just going to go in and say, well, now b is the square root of our hypotenuse squared minus our leg squared. And like I said, this will always be the case when you work these problems out. I believe in the last video I said just kind of follow the convention of a problem you're given. I see here that they've rounded to 1 decimal place, so I'm going to do that again here. And I just want to double check, always double check your calculator input. I see 16 squared, I see negative 12.2 squared, so I feel okay with that. And then here, a lot of people will have questions about rounding with 5s. 5 does count for rounding up. So when I round this, this would be 10.4. So we're going to see about 10.4. Maybe I should use an approximate symbol there, but I'm being a little lazy. We're going to see about 10.4 here, and that would be the length of that leg.